Okay, let's unpack this. We're diving into the fascinating and frankly fast-paced world of large language models. These are the AI tools, that are reshaping everything. How we write emails, how we discover new medicines. It's huge. You've probably heard of GPT, maybe Google Gemini. But what about others like DeepSeek or Grok? And how do these powerhouses really compare when you get right down into the nitty-gritty?
Yeah, today we're really aiming to cut through some of that noise. To give you a clear understanding of these, well, pretty critical AI models, we'll be synthesizing a comparative analysis, looking at various sources, focusing on their unique philosophies, their performance on key benchmarks, and importantly, what that actually means for how you might use them day to day. But we're also going to look at the bigger picture too, the market trends and some of the crucial ethical considerations that are really shaping the future of AI right now.
Right. So our mission for this deep dive is really to arm you with those key insights, those aha moments, so you can walk away feeling truly well informed, but without feeling buried under a mountain of tech jargon. You should gain a quick yet pretty thorough understanding of the current LLM landscape. So having set the stage, let's actually jump in the current landscape of LLMs. Let's unpack those four main players and their core philosophies. First up, OpenAI's GPT. I mean, their focus seems pretty clearly on general purpose intelligence. It really excels in conversational fluency, creative writing, that kind of thing. Technically, GPT uses a transformer-based mixture of experts architecture, an MOE, which means essentially it has these specialized subnetworks that only activate when needed, makes it highly efficient. And it's trained on a massive 13 trillion tokens. That gives it that really broad capability.
Then you've got DeepSeek. This one prioritizes cost-effective technical accuracy. It really shines in STEM tasks, coding especially. And what's truly impressive here, particularly if you're building an application, is its efficiency. It comes in at a remarkable, what is it, 0.0008 per thousand tokens. So incredibly affordable. And it's open source, openly accessible too.
Okay, that's a big point on costs.
Huge. Then for Google, we have Gemini. Its whole thing is multimodal integration. And this isn't just like an add-on feature. Gemini is designed from the ground up to natively process text, images, audio, video, all seamlessly. It's built on a hybrid transformer vision model trained on about 12 trillion tokens. What's particularly notable here, though, is its massive context window. We're talking 1 to 2 million tokens.
Wow, 1 to 2 million. That's significant.
It really is.
And finally, there's xAI's Grok. This one emphasizes real-time, personality-driven insights. It's often described as, witty, maybe a bit unfiltered, leveraging data mainly from the X platform. And technically, Grok is a dense transformer model, so a single, uniformly activated network, trained on roughly 12.8 trillion tokens.
And what's fascinating here, I think, is how each model really reflects a distinct approach to AI, a different philosophy. This isn't just about the technical specs, right? It's about what they're actually built to do. What kinds of problems are they optimized to solve for you? So for instance, if you need broad creative writing, well, GPT makes a lot of sense. If you're maybe a developer on a budget with heavy coding needs, DeepSeek really jumps out. And if real-time social media where maybe somewhat edgy insights are your goal, Grok probably fits the bill.
Okay, so this is where the rubber meets the road, right? How do they actually stack up technically? Let's unpack how these models perform in the trenches, so to speak. Architecturally, you mentioned they're all rooted in that transformer design, but they diverge quite a bit in their implementations. GPT and DeepSeek use that mixture of experts, the MOE architecture, which you said is like a specialized team. Instead of one massive brain, smaller expert modules activate only when needed.
Exactly, making them highly efficient for certain tasks.
Okay. But Grok, in contrast, is a dense transformer, more like a single large brain uniformly activated.
Right. And Gemini is unique again, using that hybrid text plus vision model designed for different data types right from the start.
And that context window difference you mentioned for Gemini, 1 to 2 million tokens.
Yeah, it's massive. To give you some perspective, that's like an AI remembering, I don't know, the equivalent of several large books or hours of video, all in a single conversation. So it allows for these incredibly deep, nuanced interactions without, losing its train of thought. That capability is a really significant differentiator, especially for applications needing extensive long-form understanding.
Right. Now, let's look at performance on some key benchmarks. These are those standardized tests that give us a comparative snapshot. Who leads where? So, in general knowledge, measured by MMLU, that's the Massive Multitask Language Understanding Benchmark, it's basically a broad test of common sense factual recall across like 57 subjects. GPT seems to lead there at 88.0%, Grok is close at 87.0%, and Gemini also close behind at 86.0%. So, they're all quite strong.
Very strong. Yeah. Then when it comes to coding, specifically on the human evil benchmark, this assesses the model's ability to generate functionally correct Python code GPT at 87.0% and DeepSeek at 86.5% are, well, virtually neck and neck. And this really highlights DeepSeek's specialized strength in that area, almost matching the general purpose leader. Pretty impressive for a cost-focused model.
But here's maybe an interesting twist. For math, on the AM benchmark, that's the American Invitational Mathematics Examination, designed to test higher-level mathematical reasoning. Grok surprisingly leads, with 93.3% surpassing GPT's 90.0%. That's genuinely surprising. I really wouldn't have predicted Grok leading in math, given its, social media-driven persona.
No, it's quite something. It really shows how these models can defy easy categorization. A personality-driven AI can also be a mathematical powerhouse, apparently.
Huh.
And finally, just quickly, for factuality on truthful QA, that's a benchmark designed to measure if models give truthful answers to tricky questions designed to trip them up. Gemini edges out GPT slightly, 83.0% compared to GPT's 82.0%. So a small lead there is delivering accurate information.
Okay, so beyond those raw scores, let's talk about the practical side, speed and cost. Because, for a developer or a business, these cost-performance trade-offs are absolutely crucial. You mentioned DeepSeek's low cost earlier.
Yeah.
The difference between, 0.0008 and maybe 0 to 12 cents per 1,000 tokens, that can be monumental.
Oh, absolutely. It directly impacts scalability, viability of applications, everything. And DeepSeek, for instance, it also shows remarkable efficiency and speed, achieving approximately 20% faster inference than both GPT and Gemini. Now, this isn't just some abstract technical spec. For developers or businesses running millions of queries, that 20% speed boost, it directly translates into significant cost savings and a better user experience. It makes it a really pragmatic choice for large-scale performance-critical applications.
Right, and just to recap the costs again.
Sure, DeepSeek is the most affordable, 0.0008 per 1K tokens. Grok follows, around 0.0005. Then Gemini, which has a range, 0.0002 to 0.00 cents. And GPT has the widest range, depending on the specific model you use within the family, from 0.00010 up to $1.12.
Got it. And when we talk about the next frontier, multimodality seems like a major differentiator. You said Google's Gemini truly leads the pack there with its native multimodal processing.
Yes, that's its core design. Understanding and generating content using text, images, audio, even video seamlessly.
Whereas GPT supports images, but it's through integration with DALE, right?
Correct. And DeepSeek and Grok are, for now at least, primarily text-based models.
Okay, so benchmarks and specs are one thing. But how do these powerhouses actually feel in day-to-day use? Our deep dive into, qualitative user feedback, especially from places like Reddit, reveals some really fascinating insights, things that go beyond just the numbers. For creative writing and general conversation, for example, there seems to be a pretty strong consensus. People are saying Gemini Ultra is far better, even scary good, a game changer. Some users are calling it 2-3 levels above GPT-4.
Wow, that's strong praise.
Yeah. It's perceived as being more human and more intelligent in just general conversations, although it's also acknowledged that sometimes GPT-4 can achieve similar quality, but it requires extensive metaprompting.
Ah, right. Basically giving it really detailed, layered instructions.
Yeah.
Coaching the AI almost.
Exactly, to unlock its full potential.
Interesting how subjective that user experience can be, isn't it? Now, when it comes to coding capabilities, the views seem surprisingly mixed based on what we found. Some sources are calling it a tie, noting that GPT-4 tends to make fewer mistakes overall, but Gemini Ultra might offer more advanced code sometimes and maybe better explanations. Other researchers even find both models pretty much equally proficient.
But then we also hear these user complaints that GPT-4 has become, incredibly lazy, sometimes skipping parts of code, telling the user to finish it themselves. What do you make of those conflicting reports? Is it just user perception, or are there, real underlying shifts happening?
That's a really crucial distinction. While some of it might just be subjective feeling, that laziness complaint often stems from deliberate fine-tuning choices made by OpenAI. What developers are finding is that sometimes, maybe to reduce computational cost or potentially address safety concerns, the models are just less verbose, less proactive in completing tasks fully. It really speaks to the trade-offs being made behind the scenes and how those impact real-world usability for developers. On a more granular level, though, it seems ChatGPT's code interpreter might excel at statistical analyses, whereas Gemini seems to have an edge when it comes to graphing. So even within coding, you see these niche strengths emerging.
Interesting. Okay, what about for research and information retrieval? We saw a July 2024 article pointing out that Gemini really excels in academic research, demonstrating apparently 100% accuracy compared to GPT 3.5's 70% in that specific test, being more relevant, thorough, and better referenced.
That's a significant difference for academic use cases.
Yeah. But conversely, for less complex, maybe more general topics like brainstorming blog ideas for the pet industry or something, ChatGPT 3.5 was noted for providing more lucid content, clearer writing, and also referenced responses.
So context really matters.
It seems so. And for semantic search, like understanding the meaning behind a search query, Microsoft's Bing Chat, which is powered by GPT-4, is often considered superior. All right, let's delve into some user experience features and limitations. Speed is always a big one. Gemini Ultra is widely agreed upon, apparently, as being at least 3 times faster compared to GPT-4 Turbo, which, if true, is a huge claim. But then, as you sometimes see, there are user reports of slower performance. How do we reconcile that?
Yeah, it's a valid point. While Google has confirmed that Gemini Ultra generally has no message cap, some users do observe what seems like invisible routing, meaning their queries might get sent to the less powerful Gemini Pro model during peak usage times, or maybe for non-English queries. That could certainly explain some perceived slowdowns. It's likely a resource prioritization thing on the back end. Another common user complaint, and some see this as a massive problem, is that Gemini Ultra is observed to refuse to do tasks more compared to GPT-4.
Ah, the refusal issue.
Exactly. This is likely due to more stringent content moderation or maybe stricter safety guardrails being applied, which leads to increased task refusal, frustrating some users.
Okay. And finally, just a snapshot of multimodal limitations, at least at the time of those Reddit discussions we looked at. Gemini Ultra was primarily English, only then, and its image recognition was noted as, well, laughable.
Laughable?
That's
What?
because apparently it was using Google Lens rather than its native model, though the source did say this was expected to change.
Ah, okay. So a temporary integration issue, perhaps.
Maybe. Whereas GPT-4 at that time already had more plugins available, like the code interpreter, which expanded its capabilities in different ways.
So stepping back, this all raises a really important question. What does this mean for the future of AI? And, for us, the market for these large language models is just experiencing explosive growth. It was estimated at, USD 5.6 billion in 2024 and projected to skyrocket to USD 35.4 billion by 2030. That's a compound annual growth rate of nearly 37%. It's massive.
It's huge numbers. What's driving that?
Well, several factors. The ability to train systems with zero human intervention, advancements in transfer learning, powerful hardware becoming more accessible, GPUs, TPUs, and just the vast amount of internet data available for training. Geographically, North America currently leads the market, about 32.1% share in 2024. And these models are finding really diverse applications. Chatbots and virtual assistants hold the largest share right now, around 26.8%. But also customer service, content generation, and even these highly specialized models, like the one NASA and IBM built in the US specifically for earth science, tailored for industry needs.
Looking ahead then, what are the key trends shaping the future of generative AI? Because it seems like things are moving incredibly fast. Multimodal AI seems to be truly taking center stage. This vision of an AI writing a script, generating the visuals, composing a soundtrack, all from one prompt, that feels like a true leap forward.
Absolutely. And hyper-personalization is another major trend. Imagine generating unique product descriptions for every single user or virtual try-on experiences, maybe even truly personalized healthcare plans. We're also seeing this significant push towards AI democratization. Open source models becoming more prevalent. That lowers entry barriers, which is great for innovation, using tools like Hugging Face's transformers. But importantly, it also increases certain risks, like the potential for deepfakes becoming easier to create and more widespread.
Right. And energy efficiency. Sustainable AI. That seems critical given the scale these operate at.
It's becoming huge. The energy footprint of LLMs is growing, so there's a strong focus on techniques like model pruning, making models smaller without losing capability, specialized chips like TPUs and more efficient GPUs, and even building carbon-neutral data centers. It's a complex area, though. It's been noted that sometimes efforts to increase model fairness can inadvertently decrease sustainability, so there are trade-offs. Then you have the rise of AI agents. These are more autonomous systems, capable of performing multi-step tasks. Things like managing your calendar, sending emails for you, predicting market trends, maybe even negotiating simple deals. This isn't just about answering a query, it's about active execution in the world. We're also seeing secure and watermarked generative content emerge. Technologies from Adobe, Microsoft trying to ensure traceability, to combat misinformation, support copyright. And finally, AI-powered video generation. Text and video models like OpenAI Sora, Google DeepMind's VO3. These are set to really revolutionize creative industries. Imagine typing a script and getting a full video.
It's kind of mind-boggling. But as these models get more powerful, more ubiquitous, what about the challenges? The ethical side of things. Our deep dive into the research certainly revealed some critical areas that the industry is, well, actively grappling with.
Yeah, one of the core challenges revolves around just ensuring the reliability and safety of these models. Yeah. We still see issues like hallucinations, right? Where LLMs produce very professional-looking content that can be just factually incorrect. It's a widespread problem. And kind of ironically, inaccuracies tend to increase with model size in some cases. And there's always the potential for generating unsafe or dangerous content, particularly for vulnerable populations like children, if not properly mitigated. Things like bad legal advice or incorrect maintenance tips.
And tied right into that is the challenge of understanding how these models are learning. What data are they using? We often hear about the black box nature of LLMs. It's hard to trace their reasoning, which can lead users, maybe subconsciously, to attribute too much authority to their outputs.
That's a real concern.
And this also ties into privacy and data governance, doesn't it? Many LLMs train on these massive internet data sets. The question of consent for using that data, especially if it includes private info or data scraped from breaches, is a really complex one the industry is still working through.
Exactly. And another really significant area is around fairness and representation. Probably the most common issue identified in research is biased training data, which can lead to biased or sometimes even toxic outputs related to gender, age, ethnicity, socioeconomic status, you name it. It's a constant effort to curate data and fine-tune these models to ensure they reflect a diverse, equitable understanding of the world, rather than just perpetuating existing societal biases, which are often baked into internet data, often reflecting, frankly, Western white populations predominantly.
And finally, there are those broader societal and economic impacts. Concerns about job displacement, particularly for white-collar and creative professionals, they feel very real to a lot of people.
Right.
The environmental footprint, too.
Right.
The significant energy consumption, the emissions from training and running these huge models, that's a growing concern developers are trying to address. More efficient architectures, carbon-neutral data centers, as you mentioned.
Right. And it's not just technical problems either. Think about the human annotators, often in developing countries, who prune the training data. They can be exposed to large amounts of really unwanted, inappropriate content as part of that job.
These aren't just technical hurdles. They're deep questions about how we integrate this incredibly powerful technology responsibly into our world.
So if we try to put this all into a wider context for you, the listener, it's clear we're in a really dynamic phase right now. The best model today might genuinely be surpassed tomorrow. Your choice should really be guided by the specific task you have at hand. There just isn't one single best LLM overall. The ideal choice for you truly depends on your specific needs. Are you looking for, say, cost efficiency for large-scale STEM projects? Or top-tier creative writing? Or maybe real-time social media analysis? Deep academic research? Cutting-edge coding assistance? You'd point to a different potential answer. This field is in a constant AI arms race, if you will. Models are rapidly improving, new features rolling out seemingly all the time. This ongoing competition, while maybe complex to follow, ultimately benefits users like you. It pushes the boundaries of what's possible. But it definitely requires continuous awareness just to stay current with the changes.
That's absolutely right. And that's why it's just so important to understand the nuances beyond the marketing hype, beyond the headlines. We really encourage you to experiment where possible, maybe with free trials if they're available, and to just thoughtfully consider the broader implications, including the ethical ones, as you integrate these powerful tools into your work or your daily life. So recapping briefly, we've seen how GPT offers that versatility. DeepSeek brings affordability, Gemini provides that unique multimodal power, and Grok offers those real-time, maybe personality-driven insights. The landscape is incredibly rich, full of trade-offs, and the future is certainly going to be fascinating as these technologies continue to evolve at speed.
And maybe just to leave you with a thought, this raises an important question, I think. As these AI models become increasingly capable of independent reasoning, task execution, blurring the lines between being just a tool and becoming more like an autonomous agent. How will we, collectively, define and enforce accountability for their actions, particularly when the underlying truth that they learn from is itself constantly shifting and often contested?
That's a deep question to ponder. Thanks for joining us on this deep dive into the world of large language models. Keep exploring, keep questioning, and we'll be here to help you unpack what comes next.